And now for example 7. Determine the effective rate charged if a loan of $30,000 is to be paid off with quarterly payments of $1,000 over a term of 18 years. In this particular case, we have to note that the payments are made quarterly. We've got quarterly payments, and we're asked to determine the the effective rate. And effective means compounded annually. That's what effective always means. And so now let's concentrate initially on the time diagram. Let's see what we can come up with. We've got a loan of $30,000. That represents our present value. So at the 0 point in our timeline, we have a present value of $30,000. And we're going to be paying off that loan with quarterly payments of $1,000. So we'll be making 1, 2, 3 quarterly payments of $1,000 until the loan is paid off. In fact, we're told that the loan will be paid off in 18 years. And 18 years of quarterly payments means that we will have 18 times 4, or a total of 72 quarterly payments. So we've got 72 payments of $1,000. So that'll be paid with, let's see now, 72 payments times 1,000. We're going to be paying $72,000 over that time period. That will definitely cover the interest here. So we've got $30,000 principal and a $72,000 of payments. So that means that we're going to have $42,000 in interest alone over that 18 years. Let's wrap an annuity bus around this and say, here's our quarterly payment. So we've got per quarter. And obviously we're going to need to use the present value formula to solve for the interest rate. So we're going to have $30,000, that's our present value, and that's equal to $1,000 per quarter multiplied by the discount factor. 1 minus 1 plus the interest rate per quarter, negative 72, divided by the interest rate per quarter. So we use the present value formula, and this is the formula that we use for ordinary simple annuities. So initially what we're going to need to do is to solve for the interest rate per quarter and then convert from the quarterly rate to the effective rate so that we can have the equivalent rate. In order to solve this equation for the interest rate, we'll need to solve by dividing by $1,000. So we'll divide the left side and the right side by 1,000, and we'll end up with a factor of 30 equals to 1 minus 1 plus I to the negative 72 divided by the interest rate. So in other words, we need to come up with a factor of 30 for when we substitute an I value into this factor here, and we need to narrow it down so that we're at least within 0.5%. This is the interest rate per quarter. We need to be within 0.5%, so we'll take one shot above 30 and one shot below 30 and see if we can interpolate from that. So we have to find an interest rate per quarter that will give us a factor of 30 with a number of payments being 72. Now, in order to do this, we're going to have to approximate, and obviously we're going to have to go through a trial and error process until we narrow it down so that we are within 0.5%. We need to be within 0.5% spread, and we need to take one shot above and one shot below 30. Our target is 30. So if we have a quarterly rate, it's not reasonable to start off with something like 10% per quarter. But if we started off with something like 12% compounded quarterly, and I divide that by 4, my starting value is going to be 3% per quarter. So 12% compounded quarterly is going to be a good starting point. 12% compounded quarterly means that we're going to try I is equal to 0.03 or 3% per quarter. And when I plug in 3% per quarter into this annuity factor, we'll end up with a value of 1 minus 1.03 to the negative 72 divided by 0.03, and that gives me a value of 29.36508 and so on. In fact, what we're going to do is we're going to round that off to 2 decimal places for simplicity's sake. So I end up with 3%. I end up with a factor that is under 30. So remember that these are present values, so they work in opposite direction. So if I'm going to wish to go higher than 29 in order so that I can get a higher value than 30, then I need to drop my interest rate. So let me try I is equal to 2% per quarter. 2% per quarter is the same as 8% compounded quarterly. And when I plug in a value of 2% per quarter into this annuity factor, I'm going to end up with 1 minus 1.02 to the negative 72 divided by 0.02. And this will result in a factor of 37.984 and so on. So again, we see that one is above 30 and one is below 30. So this is great because now we know that the interest rate is somewhere between 2% per quarter and 3% per quarter, because 30 is somewhere between 29 and 37. So I guess now we're going to try I is equal to something between these two, or 0.025. So let's plug in 2.5% per quarter and see if we can narrow it down. So 1 minus, this will result in 1 minus 1.025 to the negative 72 divided by 0.025. This will give us a factor of 33.24 when I round that off to 2 decimal places. So what is this telling me? This is telling me that that the interest rate that will give me a factor of 30 is somewhere between, well, I'm not going to pick the 37, I'm going to pick the 33 and the 29. I know that the 30 is somewhere between those two, and I'm also happy because I know that I've now narrowed it down to a 0.5% interval. So I know it's somewhere between 2.5% and 3%, because 30 is between 33 and 29. So now I think we're ready to set up our little table of values. And so for our table of values, what we're going to do is we're going to start off with our rate. So we'll have the rate and we'll have our factor on the other column. And for the rate, we're going to start off with the lower rate of 0.025, and a factor is 33.24. If I knew what the exact interest rate was, I, per quarter, I would have a factor of 30. But I don't know what the exact interest rate is. And so now I'm going to go back and calculate and substitute in my table of values the other side, which is 0.03, at a value of 3% per quarter. My factor works out to 29.37. I'm going to round that off to 2 decimal places. And so now I've got a complete table of values, one on either side of 30. So I'm going to set up my equation in order to solve for I, and I'm going to do that by a ratio of differences. This is essentially a slope calculation. So I minus 0.025 divided by 3%, 0.03 minus 0.025 is equal to the equivalent ratio on the other side. 30 minus 33.24 divided by 29.37 minus 33.24. Now we have a very simple equation. It doesn't look that simple, but in fact it is simple because it's just a ratio of differences. So we can solve for the interest rate by saying I minus 0.025 divided by 0.005 is equal to negative 3.24 divided by negative 3.87. And now you'll recognize, of course, that the two negatives will give us a positive, and so we'll have I minus 0.025 divided by 0.005 is equal to a positive number, positive 0.837, and so on. Leave that number on your calculator display because now you're going to multiply by 0.005. So we'll end up with I minus 0.025 is equal to 0.00418, and so on. Again, leave that number on your calculator display because now what you need to do is you need to add 2.5% to both sides of the equation to solve for I. So now we have I is equal to 0.00418 plus 0.025. I is equal to 0.029 186, and so on per quarter. I'd like you to store this number in memory 1 because no doubt we're going to be needing it. So this will be 2.9% per quarter. Now that we have the interest rate I stored in memory 1, that's 2.9186 and so on percent per quarter. We'll go back to the equation and we'll say this is an approximation. We've only ballparked it somewhere between 2.5% and 3%, and we've narrowed it down to 2.9186% per quarter. Remember that the question asked us for the effective interest rate, and so now what we need to do is to find the equivalent effective rate that is the same as 2.9186% per quarter. And the way we're going to do that is we're going to take this rate per quarter, that would be 1.029186 and so on per quarter, raise that to the power of 4 and make that equal to 1 plus my interest rate per year, because I'm looking for the effective rate, raise that to the power of 1. So I'm going to ask you to recall memory 1, which has got the 0.029186, and add 1 to that, so it'll be 1.029, and raise that to the power of 4, and we'll end up with 1.121955 and so on is equal to 1 plus I. And now what we can do is subtract 1 from both sides, and we'll end up with an effective rate, interest rate per year of 0.121955 and so on, and that's equal to the interest rate per year. And so that means that our effective rate is going to be 12.20. I'm going to round that off to 2 decimal places, 12.20% effective. So 12.20% effective is our approximate interest rate on this particular loan. Now, if you were using the BA2 Plus calculator and the built-in functions, we could very easily determine the exact interest rate on this particular annuity. Let's use the calculator functions and say, okay, we've got a present value of $30,000, so we would enter $30,000 into the present value. We have a future value of 0 because we want to pay off the loan. The loan starts off with a present value of $30,000 and ends up with a final value of 0. 72 is the number of payments, so we'd enter 72 into N, and then we need to enter in the interest and the payment periods details. So we're going to go second function IY, and for the payment periods per year, we're going to enter in 4. So the 4 is the payments per year. Hit the enter key and the down arrow button to go to the interest periods per year, and we have 1 interest period per year for an effective rate. So 1 will be equal to the CY, hit the enter button, and second quit to get out. And now we're ready to compute the IY value. And the IY value will be returned after a momentary delay. And the IY value will equal 12.1625% effective. And so that would be per year. Now, why the difference, you say? Why is there a difference of 12.1625% per year from our calculated value of 12.20% effective? Well, the difference is that your calculator will work out the exact value. There is no approximation. What we did earlier was we approximated it somewhere between let's see now, it was 2.5% and 3% per quarter. We approximated it between 2.5% and 3% per quarter with a 0.5% spread. The smaller the spread, or the smaller the interval, the more accurate our answer is going to be. But we were quite satisfied with a 0.5% spread. So our calculation by interpolation is only an approximate calculation. The calculator value is an exact calculation. So you can choose which method you wish to use on your testing and assignment materials.